means this violates the A plus BF less than 0. But in that slide, I told you that my cost index only feasible if A plus BF less than 0. Agree? That means plus sign is not the solution. Cannot be the solution because it violates our conditions, the existence conditions. The plus sign violates the existence conditions. So the only solution will be that, the negative. This is just a simple way to show you how can I get a unique solutions. And then R going infinitive. R going infinitive means, hey, don't use my control energies. That means, well, I'm sorry if you say that my gain is 0 because I cannot use your control force. And that fit these solutions. Agree? Then if you use this, that's no good because F equal to minus 2A over B. Oh no, I can still use control force feedback. That's wrong. Physically it's wrong, mathematically it's wrong. Because you can explain that if I don't let you use my control force, you can still have a forced control. Right? So you have to understand R going to infinity means if you have a R very large, not infinity but very large, you expect what? Your control force will be small. Right? Because your F will be small. So if this R going to infinity means your F going to 0. The larger R, the smaller F will have. Okay? Understand that? So you have to be. When you give them when you want to have a small force, small gain, then you make sure your R is going large. My cost index here, I don't have anything here. See, I have just one here. I let R control. If my R is small, then what happens? If R is small, if R going to be very small, going to infinity 0, then what does that mean is this is going to be very large. Right? It's not infinity, but it will be large. Don't say infinity, I say large. It's better like that. Alright? On the other hand, that means I don't care, go ahead and use my energy, whatever energy I have. Then I can be very aggressive to control my system. As long as you are very aggressive to control your system, then you need force. Right? Makes sense. Okay. So here we prove that there's only one unique solution. However, again, this only solution A less than 0. If A larger than 0 for that stable system, then you got another solution. It's got a different solution. It's only applicable for A less than 0. So optimal control can control either stable system or unstable system. Okay, you got to be careful which solution is equal to solutions. Any questions? You have to understand this first before I go on. Because if I go on, that means so I'm not talking about a single degree of freedom anymore. I will become a matrix, state, multiple state. May not be A may not be scalar, B won't be scalar anymore, and will be more very, very complicated. So this is my basic. Let's take 10 minutes break.